In figure, find the value of resistor to be connected between C and D, so that the resistance of the entire circuit between point A and B does not change with the number of elementary sets. Elementary sets means like these boxes. Suppose these three resistances are connected like that, then again, and so on. So we have to select some resistance which needs to be connected between C and D, so that equivalent resistance between A and B is independent of the number of links connected in between. So what is the idea basically? Here, let us suppose between point C and D we connect a resistance of value, say R dash, or let us suppose it is X. Okay, X is the resistance which is to be connected, so our answer would be X. Okay, and now consider these 2 points here, these 2 points, just after considering this resistance also. Let us suppose here it is C dash and this point is D dash. Okay, so if we find the equivalent resistance between C dash and D dash, and if it is equal to X again, then you can see the same thing will be repeated here again. Okay, so if we find the equivalent resistance between C dash and D dash, and if it is equal to X, then the same thing will get repeated. So again it will get repeated, and then the number of links will not affect our answer for the equivalent resistance between A and B. So ultimately the question is here that between C dash and D dash equivalent resistance of these 4 must be equal to X. So for C dash and D dash, these 3 resistances are connected in series. So in series, R plus X, so 2R plus X. Then 2R plus X and R are connected in parallel. So if there are 2 resistances R1 and R2 connected in parallel, then equivalent is R1 R2 upon R1 plus R2. So here 2R plus X is one resistance, and here R is another resistance, which are 2 are connected in parallel, and resultant must be equal to X. So resultant X is equal to what? 2R plus X means R1 into R2, R2 is R, divided by R1 plus R2 means 2R plus X plus R. So now we can simplify this equation by cross multiplying. Here you can see that 2R plus R, it becomes 3R. So cross multiplying, it becomes 3R X, and then here it is X into X plus it becomes X square. It is equal to, here you can see it is what? 2R into R is 2R square, and then it is R into X. So let us arrange this as some standard quadratic equation. So this quadratic equation is X square and then plus 2RX, as you can see 3RX minus RX, and 2R square, it will go on that side, it will become minus 2R square, so it becomes equal to 0. So this is the equation for X. So we know that solution to this equation is equal to X equal to minus B, AX square plus BX plus C equal to 0. We know that solution for that equation is minus B plus minus under root B square minus 4AC divided by 2A. And you know all these terms here. So B is 2R, C is 2R square minus, so minus B means minus 2R plus minus under root B square means 4R square. B square minus 4A C. A is 1, C is minus 2 R square. So it becomes plus 4, 1 into 2, 8 R square. Okay, so B square minus 4AC divided by 2A. A is 1, so it becomes 2. So here 8 plus 4, 12. So it is equal to minus 2R plus minus, it is 12. 12 means what? 4 into 3. Okay, 4 means outside under root 2, it becomes 2. 2R under root 3, I suppose, and divided by 2. So it becomes what? Minus R plus minus R under root 3. So one answer is clearly negative and the other one is positive. So which one is positive? X is equal to R under root 3 minus R. So it becomes R under root 3 minus 1. So it will be the value of the resistance which needs to be connected. So option B will be the correct choice.